Today, to start the next exercise, which is exercise 2.6 from the chapter number 2, fractions and decimals. So now we are dealing with the remaining portion, decimals. Fractions already we have completed. Regarding that, all the concept, all the exercises we have completed. Now we are dealing with the decimal numbers, and for that decimal numbers we are using the different properties. Then we are solving the different examples, and in the exercise 2.5 we have considered some of the examples. Now in the exercise 2.6, now we are going to consider actually multiplication. That means here we are going to consider the multiplication of decimal numbers with the whole number, or multiplication of any two decimal numbers like this. So different categories we are going to consider in the exercise 2.6. And first of all, we are going to consider the product of decimal number with the whole number. That means if you observe the given question, now here question is like this: find 0.2 into 6. So here if we observe the numbers, then it is found that the first number is decimal number, 0.2 is a decimal number, and the second number is a whole number. That means here we are going to take the product of decimal number and whole number. So here the category of example is like this: product of decimal number and whole number. Now we already seen that how to take product of whole numbers. That means you are familiar with the multiplication of any whole number, so you are familiar with that. But now here we have to consider product of decimal number with the whole number, and while considering this product we have to include that decimal point also. While considering this type of example, we have to include that decimal number also. Now there are some steps which we are going to follow while performing this multiplication, and in each type of example you are going to apply the same steps. Same steps are going to be applied in each and every example. Now the first example, we have to obtain the solution for this first example, which is 0.2 into 6. Now actually sometimes if we want to take the product of decimal number and whole number, then it is quite difficult to take product. That means if we take the decimal number as it is, then it is sometimes very lengthy to take the product. It is very lengthy to take the product. Now here in this first example, that is very simple, but if we move to the higher numbers, then it is very difficult to take the product along with the decimal point. So therefore, while solving such a type of examples, the first step is that we have to follow the first step, which is very important step. Here we are going to neglect these decimal point. We are going to neglect those decimal point for a while. That means for a temporary purpose. While performing the calculation, we are going to ignore these decimal numbers. So therefore, this decimal point I am going to remove, and that 0 is also removed, because we know that 0 don't have any value. So therefore, along with that decimal point, we are going to ignore that 0 also. So by ignoring that 0 and decimal point, we obtain the step like this. The remaining number is 2 and 6 is going to remain as it is. So therefore, if we consider these decimal point, and if we remove those decimal point, then the given decimal number is converted into whole number. So you can see that 0.2 is converted into whole number, which is only 2. Now it is very easy to perform the multiplication of any two whole numbers. It is very easy to perform the multiplication of any two whole numbers. So now here 2 and 6 both are considered to be whole numbers. So therefore we are going to take the product of these two whole numbers. So we know that 2's table, or you can also count the 6 table. So 6 1s are 6 and 6 2s are 12. 6 2s are 12. So by performing multiplication, we obtain the final product 12. 12 as a final product. 6 2s are 12. So that is the final product. But now we have ignored this decimal point for a temporary purpose. To perform the multiplication, we have ignored those decimal point. Now we have to bring those decimal point back. That means after performing the multiplication, again we have to bring those decimal point. Now, first of all, we are going to bring that decimal point in our product. So here we have bring this decimal point. Now again our original product is obtained 0.2 into 6. Okay, initially we have taken the whole number 6 into 2, that product is 12, but now we have again implemented that decimal point. So again we have obtained the same product 0.2 into 6. Now we have to put decimal point in our final answer, and that final answer is 12. That means we have to place the decimal point. Now it is very easy to keep that decimal point in our final answer. So for that purpose, you have to find out how many digits are present after the decimal point in our question. So our question is like this: 0.2 into 6. So 6 is a whole number. So that number is not considered as a decimal number. So we have to skip that 6. So we are not going to consider that 6 while considering the decimal point. So we are ignoring that 6 because it is a whole number. But now in the decimal number 0.2, in the decimal number 0.2, only a single digit is present after the decimal point. What you have to find out? You have to find out how many digits are present after the decimal point. It doesn't matter which digits are there, whether it is 0, whether it is 1, 2, 3, 4, 5, 6, 8, 9. So 0 to 9, any digit can be possible, and we have to only count how many digits are present after the decimal point. So here, after the decimal point, only single digit is present. Only single digit is present. So therefore, in our final answer, we have to keep the decimal point such that only single digit should be present after that decimal point. So therefore, we are going to put that decimal point between 1 and 2. And after putting that decimal point, only single digit is present after that decimal point. So here, only 2 is present after the decimal point, which is a single digit. So in this way, you have to keep the decimal point in the final answer. And what are the steps we had followed? First, we had taken the whole number. That means we had ignored the decimal point. Then after performing the multiplication, we have kept the decimal point such that same number of digits should be present after the decimal point in the question as well as answer. So in the question, only one digit is present after the decimal point, and in the final answer also, one digit is present after the decimal point. Now, the second example is 8 into 46, 4.6. 8 into 4.6. Now, here only the difference is that the position of numbers is changed. Nothing is changed. In the first example, decimal number is initially given, and in the second example, it is given later. So it doesn't matter. Still, we have to follow the same steps while solving such a type of example. So here, we have to solve the example 8 into 4.6. So here, if we compare the numbers, then 8 is a whole number, 8 is a whole number, and 4.6 is a decimal number. 4.6 is a decimal number. 8 is a whole number, and 4.6 is a decimal number. So again, we are going to follow the same steps which we had followed in the first example. So while performing the calculation, we are going to ignore the decimal point. We are going to ignore that decimal point for a temporary purpose. It is only temporary purpose. So here the decimal point is present in the second number 4.6, 4.6. So we are going to ignore that decimal point, and after ignoring that decimal point, the 4.6 is converted into 46. Now that number is a whole number. 46 is a whole number. Now you can solve the or you can perform the multiplication. That means if you want to perform the multiplication, so here we are going to multiply by 8 to that 46. Okay, so while performing this multiplication, how to perform this multiplication? Now you have to count the 8's table. You have to count the 8's table. Okay, now here we know that 8 ones are 8, 8 twos are 16, then 8 threes are 24, 8 fours are 32, 8 fives are 40, and 8 sixes are 48. So first multiplication we are going to take 8 into 6. So 8 sixes are 48. So here we are going to take that 8, and 4 is going to be remainder. 4 is going to be remainder. The next calculation is 8 into 4. So again you have to count that table. 8 threes are 24, 8 fours are 32, 8 fours are 32, and we have to add this remainder 4. So 32 plus 4, that is going to be 36. So here what is the product of 46 and 8? 8 into 46 is going to be 368. So product is going to be 368. So we are going to indicate that product, which is 368. 368. But now we had removed that decimal point, and after removing that decimal point we had obtained the product, which is 368. But now we have to bring that decimal point back. That means again we are going to bring that decimal point. So we know that where that decimal point is present, that decimal point is present between 4 and 6. So we are going to bring that decimal point. So we have brought that decimal point again. So now again original number is came 8 into 4.6. What we have done? Actually we had removed that decimal point for a temporary purpose to perform the calculation, and now we are bringing that decimal point back. So again we got the original number 8 into 4.6. 8 into 4.6. Now again we have to count how many digits are present after the decimal point. So here only single digit is present after the decimal. Now in the first example, after decimal point 2 is there, and here 6 is there. So I told you that don't see that which number is present after the decimal point. We have to only count how many digits are present after the decimal point. So here only single digit is present after the decimal point. So therefore here in the final answer also single digit should be present after the decimal point. So that single digit is going to be 8. So therefore we are going to put that decimal point before 8. So that's why final answer is now 36.8, which is the final answer for the second sub question. For the second sub question, the final answer is 36.8. So in this way we have removed that decimal point temporary purpose, and after performing the multiplication again we had brought that decimal point back by counting the how many digits are present after the decimal. Now another example we are going to consider, similar to that second example we are going to consider the third example. Now this third example is like this: 2.71 into 5. So here again two different numbers are there. The decimal number is 2.71 and the whole number is 5. So again same type of product we are going to take, decimal number into whole number. Now while performing the solution we have to obtain the solution of 2.71 into 5. And again we are going to follow the similar steps which we are following in the first two examples. So here the first important step is that we have to remove that decimal point for a temporary purpose. What we are going to do, we are going to remove that decimal point for a temporary purpose. So that decimal point which is present between 2 and 71, we have removed that decimal point, and due to which we obtained it like this: 271, which is a whole number, and into 5, which is also a whole number. So here we have to take the product of two whole numbers, 271 into 5, so that will be the product. So which is the product now? 271. We had removed that decimal point between 2 and 71, and now we obtain the whole number 271, and here we are going to multiply by 5 to that 271. Okay, now in the same way we are going to perform the multiplication. 5 ones are 5, so that 5 is came at last position. Then 7 5s are 35. We know that 5 7s are 35. So therefore 5, and again remainder is going to be 3. Then 5 2s are 10. 10 plus 3, 13. So therefore 1355 is the product of 271 into 5. That means we had removed the decimal point for temporary purpose, and after removing that decimal point for a temporary purpose, we obtained the product 271 into 5, which is 1355. And now the last step is that we have to bring back that decimal point from where we have removed that decimal point. So from where we had removed that, between 2 and 71, that decimal point we had removed, and again we have brought that decimal point back between 2 and 71. Now again we have to count how many digits are present after the decimal point. So here see, 71. In 71, 2 digits are there. If you count the number of digits, here 7 is the first digit and 1 is the second digit. So therefore total number of digits after the decimal point are 2. So here 2 digits are present after the decimal point. So therefore in the final answer also 2 digits should be present after the decimal point, and those 2 digits are considered to be 55. 5 5, those are the 2 digits which are present after the decimal point. So therefore we are going to place that decimal point between 13 and 55, where we are going to put that decimal point between 13 and 55. We are going to place that decimal point. So in this way we are solving the product of decimal number and whole number. Okay, so this is the third example, which is similar to the first and second example. The fourth example is again similar one: 20.1 into 4. 20.1 into 4. So here again 1 is a whole number and 1 is a decimal number. So here 20.1 is going to be decimal number. So therefore while performing the calculation, again we are going to ignore that decimal point, and by ignoring that decimal point we are obtaining it like this: 201 into 4. 201 into 4, and we have to take the product of these two numbers. Which two numbers? 201 into 4. That product we are going to take. So again you know how to take the product. 4 ones are 4, so that 4 is came as it is. Then 4 0 0, we know that 0 multiplied by any number, that answer is always 0. So 4 0 0. Then 4 2s are 8. 4 2s are 8. So therefore product of 201 is going to be 804. Product of 201 is going to be 804. Again we have to bring that decimal point back in the final step as well as in our original number. So here, by bringing that decimal point back again, we are getting the same number, 20.1 into 4. 20.1 into 4. Now just count how many digits are present after the decimal point. So easily you can say that only one digit is present after the decimal point. So if only one digit is present after the decimal point, then in the final answer also only one digit should be there, and that digit is going to be 4. It doesn't matter which digit is that, or which number is that. You have to only count how many digits are present after the decimal point. That is very important. So here in the question, only one digit is present after the decimal point, and therefore in the final answer also only one digit is going to be present after the decimal point. So this is the sub question number 4 from the question number 1. Now we are going to consider the question number 2, which is quite similar. Actually, it is similar to the question number 1, but it is only given in the word type. So it is a word type example, but the process is similar to that of question number 1. So here, what is given? Find the area of rectangle whose length is going to be 5.7 centimeter and breadth is 3 centimeter. So here two values are given. The first value is length of the rectangle, and second one is breadth of the rectangle. So here breadth is a whole number and length is a decimal number. So that means we have to take the product of decimal number and whole number. So for this purpose, you should know the formula for area of rectangle, and that area of rectangle can be calculated using the formula length into breadth. Length into breadth is the formula for the area of rectangle. So now just place the values. Value of length is 5.7 and value of breadth is 3. So again we are taking the product of decimal number and whole number. So again, what is the step? Remove that decimal number for a temporary purpose, and after that we are getting the numbers 57 into 3. Those are the number. So just perform the multiplication. We know that 7 3s are 21, so remainder is 2, and 5 3s are 15, so 15 plus 2, 17. So 171 is the product. 171 is the product, and again we have to brought that decimal point back. So after decimal point only single digit is present. After decimal point only single digit is present. So therefore in the final answer, after decimal point only single digit is going to present, and therefore we can say that the area of rectangle is going to be 17.1 centimeter square, which is the area of rectangle whose breadth is 3 and whose length is 5.7. So in this way we can solve the examples, that means product of decimal numbers and whole numbers. Now we are going to start the next example from the chapter number 2, fractions and decimals, exercise 2.6. Question number 1 and question number 2 we had considered in the previous lecture. Now here we are going to start the question number 3, again, which is similar type of example. Find, again here we have to find the product of any two numbers, and among those two numbers the one number is going to be decimal number and another number is going to be whole number. But here in each and every case that whole number is going to be 10, because in this question 3 that whole number is going to be either 10 or multiple of 10. That means multiple of 10 means 100, 1000, like this, 10, 100, 1000, 10,000, like this. Now here actually we are going to use the old method also, that means the first method also, which we had followed in the first example, or question number 1. In that question number 1 we had considered some methods, and now in the similar way we are going to use that method also, and some additional method also we are going to discuss to solve the question number 3. Now already we have considered that the steps, that means if we consider the steps to solve this example, then it is clear that, or first of all, we are going to remove that decimal point. That means for a temporary purpose, we are removing that decimal point, and after performing the calculation, again we are putting that decimal point back. So here, same method we are going to follow. Again here, we are going to remove that decimal point for a temporary purpose. So in the whole number 1.3, we had removed that decimal point, and due to which that number is now become a whole number, and which is considered as 13, and that second number is going to remain as it is. That second number is going to remain as it is. So here we had removed that decimal point for a temporary purpose, and after removing that decimal point, we had obtained the numbers like this: 13 into 10. Now we know the tens table, so we have to multiply this 13 with the help of 10. So therefore we are going to multiply is, so 10 threes are 30, so 3 is going to be remainder, 3 is going to be remainder. Then 10 ones are 10, 10 plus 3, that will be 13. So therefore the product of 13 and 10 is going to be 130. The product of 13 and 10 is going to be 130. So therefore we can write that product 13 at 130 as it is. So now here we had obtained the product after removing the decimal point, and now the next step is that we have to bring that decimal point back again. So again, same method we are going to follow. So here in 1.3, if we consider the position of decimal point, then its position is such that after decimal point only one digit is present. After decimal point only one digit is going to be remain. So therefore in the final product, after decimal point, again single digit should be there, and that single digit is now 0. That single digit is now 0. So therefore after 13 we are going to put that decimal point, and therefore the final product is 13.0 is the final product of 1.3 into 10. And here you can also remove this 0. That means you can only write down 13. That means you can also cancel that 0, and after cancelling that 0, only 13 is also acceptable. That means you can also write down only 13, or you can also write 13.0. Both numbers are accepted. So in this way we are performing the multiplication. Then the second example is also similar type of example. Now here, if we consider the next example, which is 36.8 into 10, 36.8 into 10, which is the next example. Again here, the first number is a decimal number and second number is a whole number. So again, here we have to take product of decimal number and a whole number, and that whole number is again 10. So I told you that in this question, all the whole numbers are 10. So here again that whole number is 10, only that decimal number is changed. Only that decimal number is changed. Now here again, while performing the multiplication, we have to remove that decimal point for a temporary purpose. So due to which we obtain that number like this, 368 into 10. We had removed that decimal point which is present after the 36. So we had removed that decimal point, and due to which we obtained the whole number, which is 368 into 10. So here our product is like this. So which product we are going to take now? That 368 into 10, that will be the product, and here we are going to perform this multiplication. Now how to perform this multiplication? We know that 10 ones are 10, that means we have to count the tens table. So if we count that table, then we will find that 10 eights are 80, 10 eights are 80. So therefore here 0 will be taken downside and 8 is going to be remainder. So here 8 is going to be remainder. Then next one, 10 6 are 60, 10 6 are 60, and plus 8. So 60 plus 8, that will be 68, and 8 we have to write down as it is, and remaining 6 will be the remainder. 6 will be the remainder. Then last product is 10 3s are 30. 30 plus 6, that will be 36. So therefore, the final product of 368 into 10 is going to be 3680, which is the product of these two whole numbers. Now, we had taken the product of these whole numbers, but actually the question is in the form of decimal number. So that means we had removed the decimal point for a temporary purpose. Now that purpose is satisfied, so we have to bring that decimal point back again. So here that decimal point is between 36 and 8, and after putting the decimal point, we have to count how many digits are present after the decimal point. So here only one digit is present after the decimal point. So therefore, in the final answer also, there should be one digit after the decimal point, and which is 368.0. So therefore, final answer is 368.0, or you can also write it like this, 368. That means you can also write it only 368, or you can also write it as a 368.0. Now, these are the regular methods which we had used in the first example. Now here, if we observe these both the examples, then we can get one very shortcut trick or one very shortcut method to perform the multiplication of such a numbers. That means such a decimal numbers which are multiplied by 10. This is only applicable to multiplied by 10, multiplied by 100, or multiplied by 1000. So such a type of multiplications are there. So this trick is only useful to the product of decimal number and 10, 100, 1000, 10,000, like this. Now here you have to count how many zeros are present in whole number 10. So by observing this number 10, you can easily find out that only one zero is present in the whole number 10. If we consider 100, then in case of 100, two digits are present. In case of 100, two zeros are present. So here you have to count how many zeros are present. So here in case of 10, only one zero is present. So you have to shift the decimal point by that number of digits. Which number of digits? The number of zeros. So if one zero is present, so we have to shift the decimal point by one digit. If two zeros are present, then we have to shift that decimal point by two digits. In this way, you have to carry on. So here only one zero is present in number 10. So therefore, we have to shift the decimal point by one digit to the right hand side, where we are going to shift that decimal point to the right hand side. So here in the 1.3, you have to just shift that decimal point to the right side by one digit. So therefore, that decimal digit or decimal point is shifted after 3. So therefore, after shifting that decimal point, we are getting the number 13.0. So here, this method is useful if you don't want to calculate it. That means if you don't want to use this method, remove that decimal point for a temporary purpose, then perform the multiplication, again bring that decimal point, count how many digits are present after the decimal point, and put down that decimal point like this. So if you want to skip this method, multiplication method, in case of whole number 10, 100, 1000, like this, then you can shift the decimal point to the right hand side. And how many digits you have to shift? You have to shift those number of digits that number of zeros are present in 10, 100, and 1000, like this. So if we take the 100, so if we take the this product is like this, 1.3 into 100. So in case of 100, how many zeros are there? Two zeros are there. In 100, two zeros are there. So we have to shift this decimal point by 2 digit to the right side. So 3 and 0. So these are the two digits. We are shifting that decimal point by 2 digits to the right hand side. So therefore, your product is now 130.0, or you can also write down directly it as a 130. So that 0.0 is not necessary to write down. So in this way, if you are multiplying by 10, 100, 1000, then you have to only shift the decimal point to the right side. And how many digits should be shifted? You have to count number of zeros, and those number of digits should be shifted to the right hand side. You can also see in the second example, 36.8 into 10. So 10 is there. So we have shifted this decimal point by 1 digit. That means it is shifted after 8. So we are getting 368.0. So in this way, you have to only shift the decimal point to the right side if you are multiplying by 10, 100, 1000 and so on. Okay. So this method is only applicable to whole numbers which are in multiple of 10. Okay. Here in the question number third, that means sub question 3. Now again, the number is like this: 153.7 into 10, 153.7 into 10. Again, we are multiplying this decimal number by 10. So now here again, you are free to use any two methods. That means any one method out of these two methods. So either you can use the regular method, that means by removing the decimal point. By removing the decimal point, we are getting this number like this: 1537 into 10 into 10. And after performing that multiplication, that number is coming like this: 15,370. After multiplying, we are getting 15,370. And again, we have to put that decimal point back. Again, we have to put that decimal point back. So after decimal point, only one digit is there. So in final answer also, only one digit should be there, and which is 0. So it is not necessary to denote that 0. So you can also write down this only 1537. So that 0 is not necessary to denote. Or what is the second method here? Which method we can use? We can use shifting of decimal point to the right side by one digit. So here you have to shift that decimal point after 7, and then you are getting your answer 1537.0. So here either you can shift the decimal point to the right side, or you can use the first method, that means remove the decimal point for a temporary purpose, then perform the multiplication, again bring that decimal point, count how many zeros are present after the decimal point, and those number of zeros should be present in final answer also. So in this way, you can use any method which is simple for you, which is convenient for you. So you have to determine that only method which is convenient to you only. Okay. So don't see that which method I am using. You can use any method. Now next example is 168.07 into 10. Again, we are multiplying by 10. So here again, we can remove that decimal point. Then that decimal point is removed for a temporary purpose. After removing that decimal point, we are going to perform the multiplication. And after performing that multiplication, we are getting that number like this: 1,68,070. So that number is 1,68,070. That number is like this. Now again, we have to bring that decimal point. So here in our example, after the decimal point, two digits are there. After the decimal point, two digits are there. So therefore, in final answer also, two digits should be there. So before 70, we are going to put that decimal point. So therefore, final product is going to be 1680.7 or 1680.70. You can read it as a 70 or 7. Any number can be acceptable And what is the second method here? You can also directly shift the decimal point to the right side by 1 digit. So here this decimal point is shifted after 0, and by shifting it by 1 digit after 0, then you are getting your answer. So you are free to use any method, any one of the method to solve this example. Then next example is question number 4, which is now word example. Same type of example is there which are in the question number 3, sub question 1, 2, 3, 4. Same type of example is there, only it is given in the word, like we have considered it question number 2. So in the same manner here the word example is given. So you have to read the conditions. A two-wheeler covers a distance of 55.3 kilometer in 1 liter of petrol. 55.3 kilometer in 1 liter of petrol. How much distance will it cover in 10 liters of petrol? 10 liters of petrol. So while solving this, we have to consider for 1 liter, the two-wheeler covering a distance of 55.3 kilometers. For 1 liter, it is covering a distance of 55.3 kilometers, which is given in our example. Then, if you want to calculate in 10 liters, a two-wheeler will cover how much distance, then we have to only multiply the value of 1 liter into 10. So here total quantity is 10 liters. So we have to multiply the value of 1 liter petrol, which is 55.3. So what will be the product now? 55.3 into 10. So again you are going to use the same methods. Remove the decimal point for a temporary purpose. Perform the multiplication. We are getting the answer 5530. Again bring back that decimal point which is present after 55. That means only 1 digit is present after the decimal point. So in our answer also only 1 digit should be present after the decimal point. Or second way is that you can shift the decimal point to the right side by 1 digit. That also you can do. So that decimal point is shifted after 3. So you are getting 553.0, or you can say directly the 553 also. So therefore, the 553 kilometer is the distance will be covered by vehicle in 10 liters of petrol. In 10 liters of petrol. So in this way, we can solve the examples in which we are calculating or we are performing the product of decimal numbers and product of whole